Hey, what is up, you guys? Guys, welcome to another episode on the Incredible Academics YouTube channel. Guys, look, this video is being recorded on the 2nd of January 2024. It's an absolutely incredible morning in the south of Johannesburg, right? So, look, we are going to talk about inverse functions. Inverse functions. And everything that we've been discussing basically is going to, it's sort of like a build up to inverse function, right? Function. So, in other words, whatever that we've done, we're also going to be, we're also going to refer back to that, when discussing inverse functions. All right. So now, what is an inverse function? What is an inverse function? So the functions that we're going to be looking at, that's the linear function. So we're going to look at y. So number one, we're going to look at y ax plus q. Number two, we're going to look at y is equal to ax squared. So this is linear, this is quadratic. So we're not going to look at complicated quadratic functions. We're just going to look at the basic one, and we're also going to look at y is equal to b to the x, which is exponential. Right, we're going to look at exponential functions. So look, what is an inverse? What is an inverse? Huh? That's a big question, because you guys have never discussed, inverse functions before. Right, it's literally the first time in grade 12. So now I'm gonna give you guys a typical function: y equals to 2x plus 1. You guys agree that this is a linear function, right? It's a linear function. So to find the inverse of this linear function, right, what we're going to do is we're going to swap to find the inverse function. Swap x and y. So in other words, in place of x we substitute y, in place of y substitute x. Let's do that. So x is equal to 2y plus 1. All right, and then we make y this side with the formula. So 1 goes that side, so x minus 1 is equal to 2y. Then 2y becomes what? 2y becomes 1 over 2x minus 1 over 2. Y becomes 1 over 2x minus 1 over 2. Remember, we divided throughout by what? By the 2. So that's why it disappeared on the left hand side. So this is the inverse of y is equals to 2x plus 1. Okay? So we're going to try and plot 2x plus 1. Normally 2x would pass through the origin, but because it's plus 1, then it becomes like this. And we know it's an increasing function because the coefficient of x is positive, so we won't have something like this. So this is y equal to 2x plus 1. Fine. So this is 0 is to 1, and then the x here is what? 0 here, so it's going to be minus half is to 0. So this is your y, this is your x. So we have plotted y is equal to 2x plus 1. Now let's plot y is half x minus half. Obviously it's going to be an increasing function. Why? Because the coefficient of x is positive, okay, but it's going to be down here because you can see the y-intercept is minus 1 over 2, so 0 is to minus 1 over 2, and then there we go. We need to figure out what is the x-intercept over there. So you let your y be 0, therefore the x-intercept is going to be 1 is to 0. And if you check, the y-intercept of the main function became the x-intercept of the inverse. So this is y is equal to 1 over 2 x minus 1 over 2. They basically swapped the intercepts. In other words, we didn't have to calculate the x and y intercept of the inverse function, because there is a relationship between these intercepts, right? Intercepts of the main function and the intercepts of the inverse function. So this is inverse, okay? So you can see that this the x-intercept became the y-intercept this side, and the y-intercept this side became the x-intercept this side, so on and so forth, okay? So now, is the x is the inverse of this function, which is this? Is it a function? Remember, there's two tests. There's the vertical line test, and there's the horizontal line test, right? Each one serves its own purpose. This one is for testing if a mapping is a function. A mapping is a function. So meaning that the question that we're asking right now, we can actually answer it by using the vertical line test. But the horizontal line test is for testing if a function is 1 to 1 or many to 1. Do you understand? So now you guys can see the different ways in which you can actually use these two type of tests. So in order for us to check if this is a function, we just need to use the vertical line test. So we draw a vertical line like that anywhere, as long as it's going to cut our function. So how many times does this vertical line cut this function here? Once, isn't it? So this is a function, simply because the vertical line cuts the graph once. So the inverse of a linear function is a function. Please note that down. Right? Please note that down. The inverse of a linear function is also a function. All right? This will not always be the case. There's going to be times whereby the inverse of some type of functions is not a function. Right? It's not a function. Okay, so let's get, a couple of functions, linear functions. So let's say we've got the first one, y is equal to minus 4x plus 8. Number 2, y is equal to 1 over 3x minus 9. Number 3, let's say we've got y is equals to x minus 2 over 4. So for these functions, let's find the inverse. Let's find the inverse. Okay, let's find the inverse. And plot on the same set of axes. Okay, so we're going to plot the two functions after having found the inverse. Okay, number 1. Remember, to find the inverse, we need to swap x and y. So if we given y is equal to minus 4x plus 8, we're simply going to say, okay, x is equal to minus 4y plus 8. Okay, so we take the 8 to the other side, so x minus 8 is equal to minus 4y. Alright, so now y is equal to what? Minus 1 over 4x plus 2. So this is the inverse. So now let's plot the two functions, and okay, the main function, that's the main function. So the y-intercept is going to be at 0 is to 8, and the x-intercept is going to be at 2 is to 0. 2 is to 0. So 2 is to 0. So we join the 2. We join successfully. So we've plotted the main function. So this is y equal to minus, wait, but it's supposed to be downward sloping. Can you see that the coefficient is negative here, the coefficient of x squared? So let's see if there's something wrong that we did. Oh yes, the 2 is to 0 is supposed to be this side. Sorry about that. 2 is to 0. So the function is supposed to be like this. There we go. So it's downward sloping, so because the gradient is negative there. Okay. Yes. So this is y is equal to negative 4x plus 8. So the other function, it's easy to plot. We don't even have to find the x and y intercept, simply because we know that this y intercept will then become the x intercept of our inverse. So meaning that our inverse is going to be like this. 8 is to 0. 8 is to 0 becomes the x-intercept, and 0 is to 2 becomes the y-intercept. Alright, 0 is to 2 becomes the y-intercept, because this side is the x-intercept, so on the other side becomes the y-intercept. So there we go. 0 is to 2. Then we join the 2. We join the 2. Not so straight, but yeah. Okay. I hope you guys can see what's happening here. So this is the main function and this is the inverse function. So inverse function, y is equal to minus 1 over 4x plus 2. And you can run a test just to check. Definitely the y-intercept is at 0 is to 2. Okay. And if you put a 0 there, 2 divided by 1 over 4, that's going to give you 8. So 8 is to 0 becomes our x-intercept. So that's that. So we've got the function and the inverse being plotted on the same set of axes. This doesn't look neat, but hopefully the other function is going to look neat. So number 2, hopefully you're not going to make any mistakes. So the function is what? Y is equal to 1 over 3x minus 9. So y is equal to minus 1 over 3x plus 9. Alright, so to find the inverse, x is equal to minus 1 over 3 y plus 9. X minus 9 is equal to minus 1 over 3x. Multiply throughout by negative 3. No, it's y here. Multiply throughout by negative 3. Minus 3x plus 27 is equal to what? Y. So that's our function. So now let's do the plotting. So we've got the function and its inverse. So this is y, this is x. So this function here, y-intercept, we know for sure it's going to be at 0 is to 9. X-intercept, it's going to be at 27 is to 0. Alright, 27 is to 0. And you can see that we're dealing with a downward sloping. Where's my ruler? Because I can see that my drawings are so poor. Now I'm gonna come across as someone that's reckless. I can't find my ruler, so I have to use this. Right, there we go. So we've got our function. Right, this is the main function. Y is equal to minus 1 over 3x plus 9. Right, so remember, this is the y-intercept. It's going to become the x-intercept for the inverse. So meaning that we're going to have 9 is to 0. 9 is to 0 for the inverse. And this is already the x-intercept. It becomes the y-intercept. Okay? So let's extend here a little bit. So 0 is to 27 becomes our y-intercept. So we join the 2, then we'll have our inverse. So there's the inverse. Right, so this is y is equal to minus 3x plus 27, which is the inverse. Right, this looks way much better than the first graph that we drew. Right, so that's how you plot the main function and the inverse. It's easy to plot the inverse. I mean, you could have done the same thing whereby you got the x-intercept and the y-intercept, but if you already have the main function, you know, it's so easy. And you see that, you can see that the inverse is also a function, because if we were to draw a horizontal line here, it would actually cut the inverse once, meaning that the inverse of the linear function is always a function. Last one. All right, last one. So on the next episode, we'll try to sort of like look at quadratic functions with their inverses. For now, we're just gonna leave it at the linear function. So let's check the function that we have. So we've got y is equals to x minus 2 over 4. So y is equals to x minus 2 over 4. 4. Now how do we find the inverse? We do exactly what we did over there. Nothing is changing. X is equal to y minus 2 over 4. So multiply 12 by 4, so 4x is equal to y minus 2. Okay, therefore 4x minus 2 is equal to what? Y. So this is our function. So let's try plotting now. This is y and this is x. Alright, so here if you check, the y-intercept is going to be at what? Minus a half, isn't it? That's the y-intercept, so 0 is to minus 1 over 2 y-intercept, and then x-intercept at 2 is to 0. So 2 is to 0. And we join the 2 points and draw the function. 2 points joined. Now this is the main function. Y is equal to x minus 2 over 4. That's the main function. To draw the inverse, we simply, this is the x-intercept, it becomes the y-intercept of the inverse. So we're going to have something like this. 0 is to 2. This is the y-intercept. It's going to become the x-intercept of the inverse. Okay, so x-intercept minus 1 over 2 is to 0. And we're done. Right, we're done. So this one, it's y is equal to 4x minus 2. Okay, and this is the inverse. Okay, inverse. But look, this inverse, it's also a function, because if you drew the vertical line here, it would cut the function just once. So the inverse of a linear function is also a function. All right. So ladies and gentlemen, I think we've come to the end of this episode, and I hope you guys have enjoyed the lesson. So sometimes when they're asking you to find the inverse, they'll say find f. Okay. And obviously the assumption is that your main function will be given as f of x is equal to x minus 2 over 4. Then you know when they say find f to the exponent negative 1, they're actually asking you to find the inverse. Or maybe they say find g. All right, just know they're talking about the inverse. So in a case whereby we've got g of x is equal to minus 1 over 3x plus 9. You just know that, you do the exact same thing. This is still your y, so in place of y you put the x, in place of the x you put your y. Then you make your y the sum of the formula. Simple as that. So don't be confused by this f of x notation. All right, so that's it. I hope you guys are enjoying 2024, yeah, let's go. Peace out.